myself Dr. Jaishree Jain. I am Associate Professor in Ajay Kumar Garg Engineering College. So today we will learn about the machine learning approaches, machine learning techniques. So in this lecture we will learn about the basic machine learning and its types of learning. So firstly we should know about the what is machine learning. So we can say machine learning, it is a branch of artificial intelligence that will concern with the design and development of the algorithm. So we all know to solve any real life problem, we need to program something so that we can produce the output. So if we talk about the traditional programming, so in traditional programming we can say we have any computer system and we have the data with us, and we have to code any problem, we have to apply some logic and it will give the output. So this is the method of traditional learning. But if we are talking about the machine learning, then we can have to switch the approach. So data is already there because we have some real we have to solve any real world problem, and any problem consists of some data, and we have the output. Output means ki what we want to classify or what we want to predict from with the help of this data. So output means ki what we expect from the machine to predict. So this is the opposite of this traditional learning. We give data, we get output to the system, and machine will make the program. So what should be the program, or program means what should be the model that will fit on that data, and that will give that output. So this is the task of machine, to identify some model or program so that we can apply on that model, we can apply that model on that data and produce the output. So this is the difference between traditional programming and the machine learning approaches. So we can say it is a branch of machine learning, branch of AI. AI means we can relate it with the AI like that. AI is a super set, and under AI we have learned some model, machine learning model, and under machine learning we have to we can move to deep learning concepts. So these are the relationship between AI and machine learning and the deep learning. So it is a branch of AI, and it actually AI, what AI done, AI try to mimic the human behavior. It try to mimic the human behavior. So what human think about any problem, that will try to mimic that behavior and apply that process to the machine system. So it will be possible with the help of any machine learning models. How can we solve it? With the help of machine learning model. And what is machine learning? Machine learning refers to the system that capable of the acquisition and integration of the knowledge. It means we have to apply some statistical method. Machine learning means we have to apply some statistical method so that we can try to mimic the human behavior, and with the help of some algorithm and tool we will find the outcome. So this is the introduction of AI. So we can say machine learning is what? Machine learning is subcategory of AI, and it automate the process, and it will adapt to the new scenario. So we can say machine learning is a part of AI, and it will try to fit the model onto the training data as well as the new instances or new data, because the data can be changed every time we got at every instance data can be added on to the model. So it will also try to predict the model value on the new scenario also. So machine learning have the advantage, if we are using machine learning, we can apply that machine learning onto the old data as well as to the new data. So it will help us to predict the value on the new data also. So it will learn from the data, means this is the training data. We have two type of data, training data and test data. So if we are talking about training data, this is the data, we will try our machine learning algorithm on this data and predict the accuracy and predict the value and find the accuracy. If we find the accuracy is high, then we try to predict that model onto the test data. Test data is what? It is unseen data. Unseen data means we don't have any knowledge of that data. It come quickly, and we have to just fit the model of machine learning model onto that data also. So more data help to build more better model and higher accuracy. So we will try ki if we are applying ML to any data, then data size should be large for better performance and accuracy. So this is the definition by Tom Mitchell. The machine learning, it is a study of the algorithm that improve the performance P with some over some task T having experience E. So these are the three tuples of any machine learning algorithm. If we are applying any ML model, then we have to calculate the performance of the machine and what is the task. We have to identify the task and we have to identify the previous or past data. Past experience is what? It is training data or past data or prior knowledge. So if we have any prior knowledge, if we have known the training data, so we can apply that machine learning onto new task and calculate the performance. So it is called as a well-defined learning task which have three tuple: performance, task and experience. So this is called as well-defined learning. So a system is said to be learned with experience E over some task T and performance measure P. It means if we have any real life problem, then we can apply that machine learning algorithm onto that task and calculate the performance. Having experience means if we have any prior knowledge of that problem also, so we can consider machine will learn through the experience also. So for example, if we are playing any game and we have the in our record or in our database we have the played matches data of that game. So the machine can learn by viewing those data that are won cases. So this is the example. This I already told what is the difference between traditional and machine learning programming. So why ML? Because there is no human expert, and if we are going to apply face recognition, speech recognition, handwriting recognition, so it can't be possible by a one human that he or she can analyze or recognize onto large set of data. So we required the machine learning because there is a black box human expertise. So we required like driving car. So this is possible with the help of machine learning. Or rapidly change phenomena like financial modeling, like fraud detection. So these are the challenges actually. Movie and book recommendation. So with the help of ML model, we can easily analyze the recommendation. By viewing the recommendation, we can choose our services or customize the applications. So this is the example of handwriting recognition. If we want to find the letter 2 here, the number 2 here, so we have different kind of handwritings here. So machine can, if we feed this data into the machine and the machine know actual 2 is this, so machine can identify where 2 is written. So like this, machine can identify where 2 is written. Fine. So it can be possible with the help of machine learning. So we can see here the application like recognizing patterns like facial expressions, hand returns, like for generating the pattern or motion sequences. For motion sequences, we can create the ML and try to predict the next sequence in any video. Recognizing the anomaly like credit card fraud detections, like we can also use in prediction, yeah, like future stock market prediction. So these all are the applications like web search, finance. So these are all the applications. So what is learning system actually? How can we define or formulate any learning system? We have the input samples and we divide this sample into training and testing samples, and firstly we apply the learning algorithm on the training data set, and after that we get the learning method, and after that we apply that method into the testing data. So this is the simple machine learning problem. So what are the terminology included in ML? We all know actually if we have the real life data or any data set, then what we have in any data, this is the .csv file, comma separated version, and in any data we have row and column, like these are the attributes x1, x2, x3, and we have one class, yani target attribute. This is class. So we have number of feature. Feature means these are the selected feature on which we have to work. These all are features. Feature means attributes, or we can say variables. So features means distinct feature which is used to describe the quantitative manner. We have sample. Sample means which kind of data it contains. Sample means this is image data, this is text data, what is this, picture or sound. So we have any sample. And feature vector. Feature vector means these all feature have one value. So we can say in x1 we have number of values, in x2 we have number of rows. So these rows are actually, we can say this is one vector, and every vector have some value. If we are saying about array, then array have the similar kind of value. So this is one kind of array. So this is vector. And feature extraction means we are trying to prepare the feature vector and going to reduce the irrelevant feature and use only the relevant feature. Next is training set. Training set means we have to divide our data set into two parts, training and testing. So if we are taking whole data as a CSV file, then we can say 60% of data is as a training data we can use, or 20% as a test data, or sorry 40% as a test data. So it depends on the user how much percentage taking as a training and as a test data. So this is a workflow of any machine learning model. If we have divided our data into training and test data, so firstly we apply the model on the training data. So here we have the input sample. Then from the input sample we have to extract the features, and after extracting the feature we have selected feature, and we apply ML algorithm on that feature. And for test data we have the input data, then feature will be extracted, and with the help of this algorithm we apply that model onto the test data and find out the label of that data. Label means class of that data. So what is training? Training means it is the process of making the system able to learn. And here we have two type of data set, like this is one kind of data set, this is other kind of data set. We can, with the help of machine learning, we can easily separate this data with the help of ML algorithm. So this is, we can say, we have acquisition of data. This is the first step. We need to collect any data, and after that we have this mix of data, and with the help of machine learning model, means training set, we can easily classify this data into two sets, class 1 and class 2, by applying some machine learning algorithm. So here same process we can apply on the testing data set, but here we can see there are a overlapping of the points. There are some overlapping. So it means it is not confirmed that if any model is applicable on training data, and it will be, as well as it will be applicable on test data. So we have to change the model in case of test data. So what are the technique we use in machine learning model? First is the classification, that is predict the class from the observation. Next is clustering, that group the observation into meaningful groups. And third is the regression, that will predict the value from the observation. So it is prediction, it is classification, it is clustering means grouping of data based on grouping. So what is classification? Classification means we are going to classify our data into certain number of classes. So for step 1 we have to train the program, means building a model using the training set. For example, sports, cricket and news. Then classifier will compute the probability of each word and test with a test data against this model. It means firstly we have to acquire the data, and then we have to apply some classification model onto selected feature. So popular, like this is one algorithm of classification, name based classifier. So the image, so the data can be in the form of image or in the form of text. Then we apply any classification algorithm on training data, find the probability or prediction on the basis of probability, which probability is high, then we can say this attribute, this value belong to which class, and apply the same with the test data. So what is clustering? Clustering means, like we all know, if we going to any shopping mall, then we have different section, like kids section, men's section. So we here, if we have any data set, we can group according to value of the data, we can group the values like man shoes, women shoe, like this. So this is popular one is k-mean clustering algorithm. So it depend where we apply to classification, where data is labeled, and where we apply clustering, where data is unlabeled, means we don't know the label of the data, we have only value. If I am saying value 20, then I don't know this is roll number or this is age. So this is called as unlabeled data, where then we apply clustering on this kind of data. Next is regression. In regression, our target is, our y is continuous value. If we have any numeric value, continuous means numeric value. If we have to work on integer or float or numeric value, then we apply the regression, and regression means any kind of prediction. So y will be any value, predicted value. If we have the relationship between x or y in the form of linear, then it is called as linear regression. So x and y are correlated linearly, and we can easily classify, we can easily predict the value for the new instance because they are linearly connected. So this is regression. And what is the difference between classification and the regression? Classification give the output in the form of class, but regression give the output in the form of prediction value. It have some numeric value. So classification will give the class like harmful, not harmful, using the training data, but it will give some house price prediction or stock price prediction. So data is form of number, and here data is the form of categorical or discrete type of variable. So how we judge the performance of the any machine learning model? So we can judge the performance with the help of accuracy. Like there are some factors actually. So what are these factors? We have accuracy, we have precision. So performance can be judged by calculating these values. These are the parameters. So we can predict how accurately machine is going to give the output. If it is having high accuracy, means model is perfect. If accuracy is low, means model is imperfect. So we have to change any new model. So it is the performance, and it is one example of checker player problem, where we have the checkboard and we have two type of coin, and the target is this coin have to be reach here, means at the opponent side it have to reach here, and this have to reach here. So this is a game, and so what we have to make with the help of machine, what we want, the task is playing checker problem, and the percentage P is percentage of gain won against the arbitrary opponent, and experience is playing practice game against the itself. So we can define any machine learning problem into these three parameters. Like recognizing handwritten words is a task, percentage of word correctly classified, it is a performance, and database of human labeled image is already provided, so it is prior knowledge. So we can categorize this like that. Next is types of learning. So we have 4 types of learning in our whole machine learning. First is the supervised learning, in which we have training data and output data, means labels. So if our data is labeled, we will apply supervised learning. Unsupervised learning means we have data but label is not present, like in clustering I already told. Then we will apply unsupervised learning. Semi-supervised means it is mixed, having some labeled data and having some unlabeled data. And reinforcement means it is a form of sequence of action, means reinforcement learning is entirely different. It will work, it is a agent based learning. It will work on any, like in game we have to jump or collect the reward, so it is a reward based learning actually. So what are the different machine learning model? I already told. Supervised means labeled, unsupervised means unlabeled, reinforcement means reward maximization, and ML will be related with the AI sub-branch, and in machine learning, we have different types: supervised, unsupervised, and reinforcement learning. So in supervised, we have both predictions and classification and regression. In unsupervised, we apply clustering or probability distribution or dimensionality reduction. These will be applied on unsupervised and semi-supervised learning. And reinforcement learning means decision making, robot or chess machine. So this I already told. This is the example of supervised learning. This is the example of unsupervised learning in the form of grouping. And this is the semi-supervised. Some data is trained, but some data, black dot, is untrained. So we have to make the classification here. So this is a layman structure. Like I already told, we have to acquire the data and break it into training and test data, then extract the feature and apply some algorithm on that feature and make the predictive model. As well as in the new data, we will fetch the feature and apply the predictive model and expect the label. So this is the structure of any machine learning algorithm. So in supervised learning, we can say we are performing the classification. So we have number of feature like x1, x2, and y1 is the class, y1, y2 is the class. So we can make the relation. This can be linear, like if these are the point, this is a linear relationship between the x and y. And if we have two class, like if we are talking about classification and we have to classify whether tumor is malignant or benign. If it is a benign cancer or tumor, then it belong to class 0, and if it has malignant cancer, then it will belong to class 1. So we got some data point here at 0 class. This is the classification, and some point will be classified as class 1. So if we have any data, then we can easily classify it in the 0 class or 1 class, because y is categorical. So there are two categories, either 0 or 1. So it depends which model we will apply in supervised learning. We have different algorithm like decision tree, like naive Bayes. So it depends using which algorithm we are doing this classification. So these are all the examples. Next is unsupervised learning. In unsupervised learning, we don't know the label of the data. These are the scattered point, and we can compute their distances. Actually, if there can be one group because they are in the nearby distance. This can form one group because they are at the nearby distance. So we will calculate here Euclidean distance, and we can find the similarity based on nearest distance. We can find the similarity, which point is similar to which point. So we can group according to the lowest distance and find the similar value, similarity between the points. So this is example of genes, genomic structure. So we can group the genes according to the similar value, similarity, or based on distance we can make the group of different genes. So this can be applicable with the help of unsupervised learning. This can be a type of unsupervised learning, like organize the computing clusters. Like in one lab, we have one kind of LAN system which is connected with one type of LAN. So we can organize this cluster into different clusters. Like market segmentation, this is one business organization, this is another. So one employee belongs to this organization. So we can segment it. Like social network analysis, like astronomical data analysis, these are all the part of unsupervised learning. Then next is reinforcement learning. So I already told reinforcement learning is based on reward base. So this is the diagram of reinforcement learning. We have any environment and we have one agent. This is agent based learning. So agent will try to perform any action on the state, and when this is initial state. When agent perform any action, then it will go to the next state and the reward will be provided to that agent. So after that, agent will perform any action, move to next state, and reward will be added. This type of learning can be used in any gaming system and robotic system. So this is the agent and environment based learning. This is the reinforcement learning. So this is Mario game. This is the example of reinforcement learning where we need to apply this type of learning. So thank you. This is about the introduction and type of the learning.